Hello, welcome back. Hi, Brendan. How are you? So now let us last video we have understood. We have learned about the law of exponents, which is applicable to real numbers, and how are they applicable to the irrational numbers. Okay, so now we were working out exercise 1.5, and we have completed the first main of exercise 1.5, and we are left with another two mains, that is 2 and 3. So let us start working out exercise 1.5 second main, and then followed by the third main. Okay, so let's begin. So this second main, find the first question is 9 to the power 3 by 2. So this can be written as 9, as I told you previously. 9 is a perfect square. The moment I say 9, 9 is a perfect square, which can be written as 3 square, right? 9 is a perfect square and it can be written as 3 square. So I will write 9 as 3 square whole to the power 3 by 2. So this is equal to, applying the same formula, a to the power m whole to the power n is equal to the a to the power mn. So a to the power m whole to the power n is equal to a to the power mn. So the same formula, this is a to the power m whole to the power 3 by 2. So this is going to be 3 to the power 2 into 3 by 2. So this will be 3 to the power 2 into 3 by 2. This 2 and this 2 get cancelled. So you are left with 3 to the power 3. So 3 to the power 3 is 3 3s are 9. 9 3s are 27. Okay. So next, the second sum is 32 to the power 2 by 5. 32 to the power 2 by 5 by fact. Since 32 is, if you just see the square, 32 is not a perfect square because it does not come in any of these numbers. It comes between 5 and 6, because 5 square is 25, 6 square is 36. So you will try to find out the factors of 32. So we have seen previously the factors of 32 is 32 by factorization method. You come to know that 32 can be written as 2 to the power 5, which you have studied earlier. So now this 32, I will write it as equal to 2 to the power 5 whole to the power 2 by 5. Again, using the same formula, a to the power m whole to the power n is equal to a to the power mn. A to the power m whole to the power n is equal to a to the power mn. So I'm using the same formula, 2 to the power 5 into 2 by 5. So this 5 and this 5, the numerator 5 and the denominator 5 there is. So this 5 is nothing but 5 by 1, okay? When there is no denominator, we take it as 1. So this is equal to 2 to the power 2. So this is equal to 4. Okay. The next sum is 16 to the power 3 by 4. The moment you see 16 is a perfect square. 16 is a perfect square of 4. 16 is a perfect square of 4. So I will replace 16 as 4 square. So square to the power 3 by 4. Square nothing but 2 by 1, right? Now, again using the same formula, a to the power m whole to the power n is equal to the power mn. So I'm using the same formula and I'm writing 4 to the power 2 by 1 into 3 by 4. So 2 ones are 2 twos are. So this is equal to the 4 to the power 3 by 2. You're going to have it this way. Okay. You can further do it another way. You can further go it another way down, because here you can see 4 is also a perfect square. 4 is also a perfect square. 4 is also a perfect square. So I will write 4 as 2 to the power 2 whole to the power 3 by 2. So this I will again, this is 2 by 1, 2 to the power 2 by 1 into 3 by 2, right? 3 by 2, this 2 get cancelled. So you are left with 2 to the power 3. So this becomes 8. Fine. So this becomes 8. So you can basically, once you get it, after doing this you get a number, and even if this number is, once again you're getting a irrational number on the top. Index is an irrational number. You can just see whether the base of that number is a perfect square. If it is a square, it can be expressed as a square, then you can continue further to get a simplified further. Now the next one is, the fourth one is 125 to the power minus 1 by 3. When you say minus, what does this minus say? It is a denominator. So let's keep it as it is, no issues. 125. Now this 125 can be written as, it is not a perfect square. If you just see, 11 square is 121, 12 square is 144. So 125 lies between these two, 11 square and 12 square. 125 is not a perfect square. So I will see by factorization method. When I go by the factorization method, you have seen, when I go by the factorization method, 5 can be written, 125 can be written as 5, 5, 5. So it can be written as 5 into 5 into 5, that is 5 to the power 3. This is how I am going to write 125, because it's by going by the factorization method. So you are writing this as 5 to the power 3 by 1 whole to the power minus 1 by 3. So this is equal to 5 to the power 3 by 1 into minus 1 by 3. 3 get cancelled. So you are left with 5 to the power minus 1. This is equal to 1 by 5. Okay. Now we will see the third main, that is the third main of exercise 1.5, which means it says simplify. So what is the first sum of simplification that has been given to us is 2 to the power 2 by 3 into, or you can say this is into 2 to the power 1 by 5. 2 to the power 2 by 3 into 2 to the power. Now by what we have learned, from what we have learned, the laws of exponents, if the bases are the same, so a to the power m into a to the power n is equal to a to the power m plus n, right? This is what we have learned. This is one of the formula. This is the we have learned. So this is what we will apply in this particular sum. In this case, the bases are the same, 2 and 2. Bases are the same, a to the power m into a to the power n. So this will be a to the power m plus n, right? So this is equal to 2 to the power, I'll have to take an LCM. LCM will be 15, 5 3 is a 15. This is 10 plus 3 5 is no, 3 will go in 15 5 times. So 3, 5 times 5 2s are 10. 5 will go in 15 3 times, so this is 3. So this is equal to 2 to the power 13 by 15. So this is your answer. Fine. Now the second sum says 1 by 3 to the power 3 whole to the power 7. So this is equal to, now this, when it comes to the numerator, recall I have set a to the power n. When it comes to the numerator, it becomes a to the power minus n here, right? This is what I'm making it applicable in this sum. A by 1 by a to the power n. So this becomes 3 to the power minus 3 whole to the power 7. So now which rule will I apply? Now I'll apply this rule. A to the power mn is equal to a to the power m into n. So this rule I will apply now. So this is going to be 3 to the power minus 3 into 7. So this is equal to 3 to the power minus 21. So this is equal to 1 by 3 to the power 21. This will remain as your answer. Okay. Now let us see the third sum. Third sum says 11 to the power 1 by 2 divided by 11 to the power 1 by 4. So this is again, what do I do? Bases are the same. I bring this to the numerator. 11 to the power 1 by 2 into 11 to the power 1 by 4. Okay. 11 to the power 1 by 4. Here it will come as minus, because this has come to the top. This has come to the denominator, has come to as become as the numerator has come up, so they become minus. Now, according to what we have learned a to the power m and a to the power bases are the same, then the indexes are added. Bases are the same, indexes are added. So the same rule I will apply it now. So now see what will happen. 11 to the power 1 by 2 in plus, this into will become plus, okay, minus 1 by 4. So this is equal to 11 to the power 1 by 2 plus into minus, this becomes minus 1 by 4. This, see, plus into minus becomes minus. This is equal to 11 to the, this LCM is 4, okay, 2 minus 1. So this is equal to 11 to the power 1 by 4. This is going to be your answer. Right? See, this came to the numerator, so it became minus. So as per law, you have to add them because bases are the same, are equal, are same. So you are adding it. When you are adding it, you put it back like if it's negative, you are adding it. But when you are adding it, you get my plus into minus because there's a plus, there's a minus. When that you take the plus inside, when you multiply plus with minus, you are going to get it as minus. So minus. So you take an LCM, you get 4. So 2 will go in for 2 times 2. 4 will go in for 1 time, 2 minus 1, 1, 11 to the power 1 by 4. This is going to be your answer. Now let us see the last sum of this particular chapter, that is fourth one. It says, what is the fourth sum? 7 to the power 1 by 2 into 8 to the power 1 by 2. Okay. Now if you see this, the bases are different, but the indices are the same. Bases are different, indices are the same. In this case, so we have another rule. I hope you recollect. I have already told you, so hope you recollect. I'll show you again. A to the power m, b to the power m. Bases are different, indices are the same. Then it is equal to ab to the power m. So this is the rule which we are going to apply there. Okay. So in this case, 7 into 8 whole to the power 1 by 2. So 8 sevens are 56 to the power 1 by 2. You can either stop it here, or if you want, since 56 is not a perfect square, you can just stop it here. So it's okay. Okay. With this, we come to an end of chapter 1 of the first chapter of the NCERT CBSE book for class 9th. Hope it was fun learning with me and hope you enjoyed it. I look forward to teach you the remaining chapters to the best of my potential. I hope you have able to grasp whatever has been covered in this chapter 1 of the first chapter of the maths book in NCERT CBSE syllabus for class 9th. Happy learning. Mathematics is cool, so take it cool and study well. God bless you.